Okay, hello everybody. I see there are some questions. Okay, yesterday's session is available via a link on ClickUp. It's you'll see it's uploaded to YouTube. So let me know if you can't find the link. I will send it to you, and then you can just let me know about that. There was something else here regarding Python. Are we going to be tested on this in the exam? I can't really say no. There will be questions regarding that in the exam, but I won't expect you to actually write the Python scripts. It will rather be like the example I showed you in class, that I give you a piece of Python code and then you can just pull or explain to me what the piece of code will do. Okay. I think that is all the questions I have here. Is everybody hearing me fine? Okay, just give me a shout out on the chat if you have any problems. Please do use the chat, the talk button if you would like to say something. We're very, it's audio a bit buggy. That might be a connection problem. Unfortunately, yeah, the internet can be a bit of a problem. Okay, what we'll talk about today is a bit of the introduction about geoinformatics standards. Why do we care about standards? And then later on, hopefully when classes resume, we'll talk more about the whole thing about the data quality on which your third assignment is based. I've also decided to do some small class assignments on ClickUp that will be regarding the standard section. You guys have a week or so to complete this, to answer some questions regarding standards, etc. And then we'll swap out the answers and mock each other's work. But I will put all the information on that on ClickUp. Okay, so what is a standard? Hopefully all of you have seen standards somewhere in your life. If you can't think of a specific standard at this moment, I can show you these. If you think about it, light bulbs, we have standards. We have the screw-in ones, the Bayesian weight ones. I don't know the terms exactly, but there's at least two different types of standards in South Africa that we use a lot. Then flash drives, they all work according to a standard as well. Because if you can buy a Consync, you can buy a Toshiba flash disk, and all of them will fit into your PC. You can see the two different types of flash drives on the screen as well. Then something that I think everybody has struggled with is plugs. In South Africa, we have the normal 3-prong plug, and then sometimes we get these little guys as well, and you struggle to actually get an adapter for them. So there's a lot of standards across the world for plugs and also the adapters for them. So that is just a couple of examples of standards. I'm sure you have other ideas as well. If you think about railway lines, the width of the railway is also according to a standard. Else, how would we adjust these things every time for a new train, etc.? Road widths are according to standards and so forth. So there's a lot of examples of standards out there. So geographic information standards, what will we talk about? We'll discuss what is a standard, why do we need geographic information standards, how are standards developed, who developed standards, and then we'll later on, not today, look at specific geoinformatics standards. Okay, so definition of the standard. As with most definitions, there are various definitions available. We'll look at the ISO one. So ISO is for International Organization for Standardization. They say it defines, realize, conserves, reproduce something according to a specific characteristic. So the next one is actually a little bit better. Generally agreed upon set of criteria. So with standards development, we'll talk a bit about that later. You have a group of people, mostly called experts, that would sit together and decide upon these criteria. So if we look at the plugs again, what is the different criteria? You need to have a ground, etc. How do we deal with it if we don't have a ground, etc. Okay, and this is all based on scientific or experimental knowledge. And you need people that know the subject or field. A lot of the times, people that work in standardization are from academia, because that's where the scientific knowledge and so comes from. Then another thing is government, because in most cases, the government are the people that actually need to implement these standards. Okay, so this is a nice definition of a standard. It's a document established by consensus that is published by an approved by a recognized body. It has some rules, guidelines, and characteristics for a specific activity that creates some type of result, and this is usually controlled in some or other way. So this part about the consensus is quite important. Okay, so types of standards. So we spoke about hardware standards previously, computers, storage drives, printers, etc. That all is designed according to standards. Software operating systems. I know a lot of people will argue about Mac versus Windows, etc. That one doesn't follow the standards, etc. But all these do follow a standard to a certain degree at least. GIS follows standards, databases follow standards. If you think about databases, SQL, structured query language, that is a standard. Your internet, telecommunication networks, all those things are standards. Web services, data. If you think about your Word documents, that is according to a standard, so that we can open a Word document that I create on my PC, you can open it on your PC. So that's why standards are important. Just a couple of reasons. So why geographic standards? So these are just two examples. The first one is about the standard representation of geographic points using coordinates. So if you have a lat and a long, and you were to swap them around, you can see that you would end up in a different location. So am I somewhere in the Middle East, or am I actually in Germany? So that shows the impact of your lat and long. If we bring this a little bit closer to home, if I take Bloemfontein's coordinates and I swap the latitude and longitude around, I would be in Pretoria. So you can see the impact of your latitude and longitude. So we specify this according to a standard. Another one is your simple feature access, the common architecture. So this is a standard that tells us how our geometries are structured. So you can see you start with the geometry. It specifies a point, line, and surface. Then this can be broken up into multiple lines, etc. So this entire system tells us how do we create geometries. Okay, so geographic information is everywhere. I'm sure you've all seen it. You have your OpenStreetMap, your Google Maps, etc. There's so many examples. We have our navigation systems that's now even on our phones. Your augmented reality is becoming a lot more. So standards are written through UML. UML is used a lot in standards. If you look at the document that is under the ebooks, you'll see a lot of the times the UML is used as a graphic representation of standards. So you have the text that explains to you verbally what is the standard about. Then it's usually accompanied by a UML diagram that tells you graphically the information about the standard. So that's why UML is also quite important. Okay, back to this. We have our augmented reality, which you can see here. You have your specific location, and a lot of information can be put onto the building, etc., with all this information about a specific area. So how do we deal with all this information? Without standards, it would be quite difficult. If you capture some information, how am I going to use the information if we use different standards, different formats, etc.? We need to be able to integrate information. Okay. So one example or one aspect where it's very important is in spatial data infrastructures. If I remember correctly, after the standards, we'll talk a little bit about spatial data infrastructures. So with spatial data infrastructures, the whole idea is regarding sharing of information. So still today, there's a lot of redundant information out there. You get multiple companies that digitize the same roads, and then they sell the information for millions of rands. But the other company also has this information, but you can actually get it free. So why don't we combine these efforts as one proper data set, etc. So it's all about reducing redundancy, allowing access to information, etc. So spatial data infrastructures is usually a combination of various things. It's not just the technology, it's agreements, legislation, resources, etc. So in South Africa, we're still very much in the development phases of the spatial data infrastructure, but countries such as Canada, Germany, Netherlands, they already have very good established infrastructures for sharing information. Then your regional ones, so Inspire is in Europe. They are a very big infrastructure that actually has laws. Every country, they get you have to capture road information, you have to capture information about land parcels, etc. And all this information needs to be shared. So if we don't have standards, how do we share this information? If you think about GIS, one of the standards we use a lot is a shapefile. So a shapefile is actually a standard. And you have your data that is stored in a shapefile. Then you need to implement this standard also in your software, because the software needs to be able to read and understand this data format. So that is just an example. Okay. Okay. So, and then globally, sorry, I'm just following on the chat as well to see if there's any questions, etc. Okay, so internationally, we have this very big UN initiative at the moment, the UN Global Geospatial Information Management, UNGGIM. They have this huge push now towards the importance of standards, where they've realized that development is not possible without geographic information, and geographical information relies on standards. So it's a whole connected system. Okay, so standards generating bodies. So internationally, I think all of you have heard about ISO at somewhere. So they're probably the most predominant body out there. Then the IEC, which is more focused on electronics. Then the ISO and IEC has some joint commissions as well that do a lot of work together. The UN has a lot of standards on disaster management, your addressing, etc. And then UPU, talking about addressing, they're the Universal Postal Union. So they do a lot of work on addressing for mail purposes. So how do we write our address on a mail system, on a piece of mail, so that your machinery can read it, etc. So they are actually quite involved in ISO GIS310 that does geographic standards with this whole addressing initiative. Then regionally, there's bodies such as SEN. Nationally, I think you've all seen advertisements from the South African Bureau of Standards. You have ANSI in the US. Then in Germany, GIS up north. So all the countries usually have some type of standards regulating body. Then another interesting one is the industrial consortia. So OGC, the University of Pretoria, is actually one of the only 2 members in South Africa that is part of OGC. The other member is a private organization called Afrigis. I think some of you visited them in your first year. So Afrigis and UP are members of OGC. Then we have ISIS and W3C. I think W3C you might have heard of. They usually have a lot of tutorials and things on JavaScript, SQL codings. So they're also very big into developing those type of standards. Then we have standards regulating bodies. So who makes sure that we actually implement the standards and that the standards are correctly implemented. Okay, sorry, just excuse me for a second. I just want to grab some water. Okay. So there's also a lot of different types of standards. So you have firstly your open standards. Those are developed by your ISO, by SADS. On these ones, we say that people are theoretically on equal footing. What is meant by that is, for example, in ISO, I'm a little bit involved there. We have South Africa, which is a member, but then is our department involved? Yes, we are actually quite involved. I'll tell you a little bit about our department's involvement in ISO GIS310. But yes, we are quite involved. So Professor Kutsia, which some of you know, she is the leading expert internationally on addressing, for example. So she leads the international addressing standards. So open standards, we have the member bodies, which is our countries. So South Africa would be a member body. Then you have all your European countries, for example, and your American, Australia, etc. So that's now, for example, in ISO GIS310. So with geographic information, we said previously that Inspire is very big in Europe, and there's laws regarding that as well. So they tend to push their agenda. So that's why we say it's theoretically equal footing, because your country has one vote, but if you have a group of countries which has the same ideas, their agenda would usually pass easier. So a lot of standards get developed specifically because Europe needs it, for example. Standards are developed by consensus, but that does not mean that if you have one country that objects to a standard, the standards would not be approved. Then the industry standards, these are, you have to pay membership to this. So for example, with the OGC, we pay a very small, there's different levels of membership. So if you want a big say within the standards development body, you have to pay quite a lot of money. So that becomes like into the hundred thousands of rands per year. So within OGC, your ESRIs, your United States government, etc., those guys tend to pay quite a lot of money to have a very big say. So with UP, we are probably on the lowest level of membership, and we thus just observe what is actually going on within this organization. Within the industry consortiums, the companies can also usually take some of their products, create a standards surrounding that, and then push that towards a standard. So there were some examples from ESRI, for example, where they wanted to create a standard on RESTful services, which was in the end shut down because you could see it was a ESRI centralized standard. Then we have our de facto standards. So these are usually proprietary. There is some lock-in within technologies. So an example of that would be shapefile. shapefile is actually not a standard that's published by a body. It's a white paper that is republished, and everybody has accepted it, so that gets implemented. Okay, so ISO. It's important to know that the S and O is actually swapped around. So if you get asked what does the abbreviation stand for, it's International Organization for Standardization. ISO stands for equal. So it's the world's largest standards developing body. It was established in the 40s. It has various technical committees which then create these standards. So the different types of standards, you have the international standard, which is a full standard. This needs to be implemented, etc. Some countries say that as soon as something is published as the international standard, the country has to implement it. Then you have your technical specifications. This is like a junior standard. It's not necessarily law to implement it. Then technical reports. So that is more informative. It's more like guidance. So a guideline document. Your review summaries. This is usually your first step. We call it a stage 0 project. Usually results in a review summary. So usually you would do some research, and then the research would tell us what is the standards that we need. What do we need to produce? Where is the gaps? Who would use these? Who is the different stakeholders, etc. Then you have the technical corrigendums. So sometimes errors do occur, and this allows us to fix these errors. Okay, so there's a question, is the SABS the only organization that makes standards in South Africa? Yes. You would have companies, etc., that can also produce standards, or groups of organizations, but for wider South Africa, only SABS. So they have, for example, I was at a function of theirs a while ago, where there was some awards that went to your cement companies, etc., because they would now provide standards for these type of products, and then test the quality afterwards as well. So they are the guys that regulate standards in South Africa. Okay, so the different stages. So this just gives you a bit of an overview of the entire process. So there's 6 stages. The first one is to have a proposal. So that's the same as with any other thing. You have to have a purpose, and you need to know what you're going to do. So this is called an NWIP. Then there's a group of people that get together called experts. From every country would nominate an expert, that this person needs to know the field, etc. And they would then ensure that the country's requirements are incorporated into the standard. So this group of people would get together usually for a couple of meetings. So meetings happen at least twice a year. At these meetings they would start creating the document. Then you get your committee draft, your CD. So in this stage, you start sending the document out, and people actually provide comments for it. So countries would say, okay, I agree with this, I don't agree with that, let's change this, or maybe say what could be included to make sure that South Africa's, in this case, South Africa's requirements are covered in this document. Then you get the GIS, so Draft International Standard. So here again, this is you can see it takes 24 months to get to this document. So it's quite a process to actually publish a standard. I'll also give you some links to a presentation from Prof. Kusia actually about this standards development journey. When you think you're close to the end, you still have a couple of turns to go. So this document again gets circulated, you receive comments, and to incorporate these comments. Then you get the FLIS, the final draft international standard. Usually in this stage, it's a yes or a no. Do we publish this as a standard or don't we? And then finally, it gets published as an international standard. Then after 3 years, every standard gets reviewed. Then we need to decide, is the standard still applicable? Does it need to be reviewed? And what needs to be done? So if the project then needs to be reviewed, we jump back to stage 1 and the process starts over again. So as we said, this happens with consensus, general agreement. People can abstain or say that they are opposed to a certain standard for specific reasons. Sometimes you would vote no, just to get the people to realize that your country is serious about certain aspects of the standard. I see there's a question, let me just have a look. Okay, so the question is, as standards take so much time to be developed, does it usually happen that they are outdated before they are actually published? So with software, standards was a specific example in this case. I would say no, because standards are usually on a very high level. So they rather tell you the different concepts. They don't go into the details of implementing. So it usually focuses on, for example, let's go with the software example. If we look at the Word document, it tells you that the Word document is an XML. So, you know, that's a document with usually a lot of angular brackets. So it's an XML document. This is the general structure. This is how you would indicate things like bold, etc. So it gives you more the high-level overview, and then someone can implement it. In most cases, with a lot of standards, the standard is already sort of in use, or at least a part of it is in use by a country. And then the standard is produced from this knowledge that the country has regarding this process. And sometimes you just need to make some changes to your national process. So, for example, addressing. So the international address is busy being developed. However, this will not change the way we do addresses in South Africa. It rather gives us a type of conceptual model about how we integrate addresses in the end. So just a simple example. In South Africa, with addresses, we work in a straight line. So, and then usually our numbers also happen sequentially along this line, you know, 1, 2, 3, 4, etc. But then you get countries, usually Asian countries, that work according to a block. And then the numbers for each of these countries are assigned as the house is built. So if I build my house first, I become number 1. Then this guy becomes number 2, 3, maybe 4 is next to me, etc. So houses are developed or numbered according to different systems than in South Africa. So we can't tell a country to change their entire addressing system. We rather look at how do we correlate, how do we ensure that these two systems can communicate with each other. So how do we get these to talk to each other, basically? I don't know if that answers your question. Okay. Okay. So I'm just trying to get my train of thought in. Okay, the process involves taking into consideration all the different parties. If we go back to addressing again, when they started developing this addressing standard, they had to get various stakeholders around the table because they needed to know what is the requirements for all these different stakeholders. So, for example, you had 2 different countries. The UPU, the Universal Postal Union, came to ISO also as a stakeholder. You had the United Nations, the World Bank, all these different guys needed to come to these meetings so that you can understand all the different requirements and you can take this into consideration. Okay, so I think that gives you a bit of an idea of what the process, how it works. It's usually a lot of negotiation, a lot of arguments, but things do get solved in the end and standards are produced. So the guys that work specifically with geographic information standards is ISO GIS310. So you don't really need to remember the numbers, etc. But that is the group. So their scope is to look at standardization in the field of digital geographic information. Member countries, there are 65 members at the moment and 7 from Africa. Members are also divided into different categories. You have participating members, which South Africa is a participating member. That means you have a vote. You can be a project leader, you can be an expert, etc. Then you have your observing members. So as the name says, they just observe the process, they can attend meetings, but they do not necessarily have a vote. So this is usually for countries that do not necessarily have the resources to really participate actively. Then you have your corresponding memberships. These are just guys that would get the communications, follow the process, but is very limited when it comes to involvement. So in GIS310 there are 31 international liaisons. This is, you would recognize OGC, OASIS, ICA, the International Cartographic Association, UNECA. So various bodies would participate in this process because they have specific fields. So for example, with OGC and OASIS, when we look at standardization with web services, so anything that has to do with internet mapping, they have a lot of expertise in this and they would thus contribute to this process. The numbers, the standards from this group, usually you will see the numbers start with 191 and then some other number. The one that you will definitely know by the end of the semester is 19157, which is what we will use for assignment 3. You can have a look at the website. There's some information about various standards, etc. Also, there's a lot of nice resources. I will also upload some of this to click up. Okay, so there's a question, is ISO GIS310 only involved in the digital geographic information aspects or also regarding hardware to collect data? It's not really, there's no standards on really hardware. There is not on building the hardware. So there's some, specifically in remote sensing, there is some standards on calibration, for example. So calibrating sensors for data collection. Not really GPSs, etc. That is handled by different groups. On precision of your GPSs, or how do you represent this, we cover those type of aspects. So calibration, things like that, but not really the design, etc. of the sensors. Okay, so SBS, they publish the South African national standards. They again work on consensus. There are 400 and something committees and subcommittees. Over 600 national standards per year. etc. They also do testing and certification of products. ISO 21211 does not do testing or certification. So they only publish standards, they do not necessarily test the use of them. Okay, so there's a partnership between ISO and SABS, so we call it the mirror committee, so that's your local people. We have the SABS TC 211 group as well, which deals with geographic information. So there was actually a meeting this morning. There is 2 standards currently being developed. One of them is about addressing and data exchange of addresses. Another one is on data custodians. So there are 44 local standards that have been produced. 2 is currently in development. I think the 33 is actually maybe outdated. There's probably already like 40 something standards that were then adopted from TC211. Why do we do that? If you buy a standard from ISO, you pay in Switzer, I can't remember the currency, I just know it's CHF. But in any case, and with the rand, it's quite expensive. So if South Africa adopts the standards, then we can get them at a lower cost. So for example, at the university, we have access to all the SABS standards. So any standard that was adopted from ISO TC211, you can access it through the SABS. Okay, Open Geospatial Consortium, over 400 members. There are standards like KML. I think you might have heard about KML. That is with Google Earth, sensor services, Geo API, WFS, WMS. There are quite a number of standards. These are a lot more technical standards. So these are ones that you would go and implement into your software, where ISO TC211 is a lot more high-level standards. They do certification for compliance. So they would tell you, for example, GeoServer is compliant with the WMS 2.5 specification. So they would give this stamp of approval that says, yes, these guys implemented the standard. Okay, there's a joint working group between ISO and OGC. Because they do a lot of the similar things, there needs to be a close cooperation between these 2 groups. You can see these are just some of the examples of standards that these 2 groups work together on, and you need to ensure that effort is not duplicated and you have the correct expertise when developing standards. Okay, there's 3 more slides and then we'll stop for today, because these sessions I know can get a bit long to just listen like this. So GIS standards is important for various reasons. So this information I actually just took from the ISO website. One of the first things is business. Standards allow is a strategic tool and guideline. It can help you operate effectively. Examples from that is cost saving. If there is a better solution for your operations, how to produce a product, etc., that will optimize your performance and it will improve your bottom line. You will save money. Enhance customer satisfaction. If we talk about this whole cement thing again, I want cement that actually will keep my building structurally sound. And so if it gets tested, I know it's a good quality. Else, if it's just someone that does their own little mix and it's not tested, you might have some problems. Then access to a new market. So there's a lot of things that says this prevents trade barriers. So if you think about, I know with fish, etc., there is some standards about the temperature at which it needs to be stored, etc., when it gets transported to a global market. So all these things ensure that you can actually do trade across borders. Market shares, when you can start doing this trading globally, it increases productivity, it gives you a competitive advantage, and then there's always environmental benefits. So when you follow these best practices, in some cases, it can reduce negative effects, and so there's a lot of different things that can actually help. Okay, can SABS and ISO have different standards on one project, or can ISO change the standard of SABS? In South Africa, we can have different ones. In other countries, such as Europe, as ISO standard becomes law, so there can't be anything that clashes with it. So again, if we go to the addressing, there is the international addressing standard, then we have a local addressing standard. These two complement each other, but they do differ. So you need to make sure, so in South Africa we decided we are going to follow the international one, but there are some things that cannot work, so we will change that in the national one. Okay. Society, again, you have confidence that your products are safe, reliable, and good quality. There's a lot of other things there, but it all comes back to quality management. When we know that something has been tested and approved, I don't know if you've seen these advertisements from SABS. I'll see if I can upload the link to it, where they say like your tire and whatever, if it has the SABS stamp of approval, you know it's safe and a good quality, etc. So it's very similar to that. Then government. So standards development, you require experts, but also in most cases you can actually also train people, and people can become even more, can gain expertise, knowledge from these different processes. So you might have someone that comes from a different background but do know a little bit about databases. Now they attend a GIS standards meeting, they would gain additional knowledge. So you also build capacity. Expert opinions, your country will benefit from knowing what standards are available, which ones need to be implemented, so that your national processes can improve, your service delivery can improve. So, and then opening up the world to trade, again the whole export imports of goods. So these are just a couple of examples of the importance of standards. There's a lot more. We have already looked at some examples of GI standards, specifically with the lat long, how to specify your different geometries, etc. So there's a lot of things that actually get influenced by standards. Okay, so is there any questions? I think now we get to the normative, informative. I think I'll stop here for today. The next part is going to be specifically about different standards, so that would relate to your assignment 3. This first part, there might be a little class exercise that I would give you guys to do. That's for marks, but I will upload information on that when I finalize it. There's just a question. Okay, so why do we need to pay for standards? That is basically the question. So if standards are beneficial to everybody, why do we need to pay for it? One answer here is intellectual property. That is maybe, I'm not so sure if that is probably true. I would also say that your country needs money to be able to send people to a meeting. So there's a lot of resources that go into the development of standards. So I think it's just a matter of covering costs in some way. So I know with the ISO, they charge per page. So that can get quite expensive when you have quite a big document. But in South Africa, these things are also subsidized a bit, so that's why the prices are lower. But SABS is an organization, so they need to make money to be able to send people to go to meetings, to go and create standards, etc. So it's a whole process, and for that reason, they do need to charge. I know that the money they make from standards, from selling it, is actually a very minute, small amount of money, and that the whole conformance testing is actually a larger part of their money-making part, their business. So selling of standards is actually not a profitable business. I see there's some typing, so we'll just wait to see if there's some questions. Okay, so why is there a difference between national and international standards? Different requirements. So if you think of the whole addressing one again, what one country needs and what another country, their needs are different. So that's why they are different things that they are looking for. What mostly happens is that you would take the international one and you would create something called a profile, which you select certain parts of the standard, decide if it's something that should be mandatory or optional, and you create a specialized version of the standard. So specifically for geographic information standards, there is currently 65 standards and projects within ISO TC211. Most of these get adopted as is into the national system. The ones that were adjusted is, for example, metadata, because in South Africa we do have some specific requirements for metadata. One thing is, for example, the languages. We need to be able to cater for more than one language. The majority of the countries also have at least 2 languages, but if you go to France, their metadata is only in French, US only in English, etc. So there are some unique requirements that we have, so thus we create a profile. Another thing is, for example, Europe, they might have villages, etc., but their definition of a village and our definition of a village is not the same. So that thing needs to be clarified.